In this lesson, we will be writing expressions or series into sigma notation. I would like to say that there are different approaches into writing an expression into a sigma notation. So you may be seeing different sets of sigma notation that represents the same series. So in this specific lesson, we will be covering the easiest way for us to write a certain series into a sigma notation. Let's consider this example. 3 plus 8 plus 13 plus ... plus 218 plus 223. So first is we're going to identify a pattern that is inscribed within our series. So from our first term, we have 3. 3 plus a certain number, we will be arriving at our second term, which is 8. So we know that we need to add 5 so that we have 8 as our second term. And from 8, we need also to add a certain number so that we have a falling number of 13. So that is also positive 5. So we can say that the constant difference is positive 5. We can also verify that from 218 up to 223 is positive 5. So the common difference here is a positive 5. So we can conclude that from our first term, which is 3, we need to add 5 times 0 so that we have 3 as a result. And for our second term, that is going to be 3 plus our second term is 8. 3 plus 5 times 1, right? That is 8. Plus for our third term, which is 13, 3 plus 5 times 2. And then if you're going to repeat this one, you're going to multiply 5 times 3, 5 times 4, 5 times 5, up to the last term of the series. So we can now conclude that our working summand is 3 plus 5i, where I, we can start from 0. Since we started from 0, for us to come up with the first term of 3. And the next thing that we need to identify is the number of terms so that we will be able to come up with 223 as the last term in the series. So to do that, we're going to convert our working summand. We're going to replace I into n because n is the representation of the number of terms. So instead of I, we're going to replace it with n, and then we're going to equate this to the last term, which is 223. And then we're going to solve for n. 5n equals 223 minus 3, that is 5n equals 220. We're going to divide both sides by 5. We have n equals 44. So we have started from I equals 0 and we're going to end into 44. So our summation now is the summation of our summand, which is 3 plus 5. So that is 3 plus 5i. We started from I equals 0. So we have 3. And our last or our upper bound will be 44. And we can verify our 44 by simply replacing I with 44. So let's say if I equals 44, are we able to get 223? Let's see that. We have 3 plus 5 times 44. 3 plus 5 times 44 is 220. So we have 223. So we have verified that our last digit matches the last digit or last term in our series. So our working sigma notation for this series is